In the last 2 decades, Elon Musk has pushed boundaries in ways most people would have thought impossible. He didn't just create cars that run without gas. He made them stylish, powerful, and capable of driving themselves. He didn't just launch rockets, he landed them back on Earth, making reusable spaceflight a reality. Every time the world thought a barrier was too high, Musk's companies came in and redefined what was possible. And now, attention is shifting toward something that could completely reshape travel as we know it: a fully electric airplane. Imagine the skies no longer filled with the thunder of jet engines or the thick plumes of aviation fuel exhaust, but instead with sleek, whisper-quiet Tesla planes gliding effortlessly from city to city. In 2026, the conversation is heating up, and the idea is no longer science fiction. It's a serious possibility, one that could shock the entire aviation industry and leave competitors scrambling for answers. Picture this: a plane that merges the elegance and exclusivity of a private jet with the accessibility and efficiency of everyday transport. Instead of spending hours stuck in traffic or standing in long airport security lines, you could step onto a compact Tesla-designed craft that lifts off vertically from a rooftop pad, accelerates smoothly through the sky, and lands gently just a few hundred miles away, all without burning a single drop of jet fuel. It's not just about luxury or innovation for innovation's sake. It's about a radical transformation of how humans move. The potential here is enormous. The first question people ask is simple: how could a Tesla electric plane possibly combine the luxury of a private jet with the affordability and practicality needed for everyday travel? The answer lies in design, philosophy, and materials science. Unlike traditional aircraft, which often rely on aluminum alloys, this next-generation Tesla craft could be built with carbon fiber reinforced polymer composites. These materials aren't just lighter, they're far stronger and more flexible under stress. In fact, they can reduce structural weight by more than 20% compared to standard aerospace aluminum, freeing up critical weight allowances for larger, more energy-dense battery packs. That weight savings means Tesla engineers could push the boundaries of what's possible in range and performance without sacrificing comfort. The fuselage would likely be sleek, but aerodynamically tapered, minimizing drag while maximizing space inside. Musk has always insisted that design isn't just about how something looks, it's about how it works. Tesla interiors and cars prove this with their minimalist layouts and oversized displays, creating an experience that feels futuristic yet user-friendly. In an electric plane, that philosophy would carry over. Wide seats, panoramic windows, advanced climate control, and personalized digital interfaces for passengers. Imagine flying with the quiet hum of electric propulsion, reclining in a seat that rivals first-class luxury, all while knowing the trip costs a fraction of today's private flights. But luxury doesn't matter if the aircraft can't perform. That's where Tesla's relentless drive for efficiency comes in. Engineers could optimize the carbon fiber layups, placing unidirectional plies where stresses are highest and woven cloth composites where curves and contours demand flexibility. The result? Tensile strengths exceeding 800 megapascals, stiffness ratings that rival or surpass the very best aerospace-grade metals. Even the outer surface would be refined down to a microscopic level, with roughness lower than 50 microns to reduce drag. When combined with faired wing-body junctions, the aerodynamic drag coefficient could plummet to as low as 0.018, well below the 0.025 or 0.030. Seen in most small aircraft today, that seemingly small improvement translates to real-world gains of 8 to 15%. More cruise efficiency at 300 kilometers per hour. Now think about what that means. A plane that not only flies cleanly, but also does so using less energy than anything comparable in the skies. Every kilowatt counts, and in aviation, reducing drag by even a tiny margin can extend range significantly. Pair that with Tesla's ever-advancing battery technology, such as hide-inside a lithium metal or even aluminum-ion breakthroughs, and suddenly flights of several hundred miles become entirely feasible. Short-haul, route, traditionally dominated by fuel-burning regional aircraft, would no longer make sense. Why burn expensive jet fuel for a 300-mile hop when an electric Tesla plane could do the job more quietly, comfortably, and at a lower operating cost? Skeptics often raise the issue of aviation regulations and safety requirements. Could an electric plane truly meet the rigorous demands of flight certification while still offering Tesla-level comfort? The key lies in systems integration. Tesla has already proven that it can merge hardware and software seamlessly. Its cars are essentially rolling computers, with real-time over-the-air updates that improve performance long after purchase. In aviation, that approach would be revolutionary. Instead of static systems locked at certification, Tesla planes could receive continuous upgrades, autopilot refinements, improved efficiency profiles, smarter navigation algorithms. Safety wouldn't be an afterthought. It would be actively enhanced throughout the aircraft's lifespan. Imagine stepping into a cabin where every seat has its own AI-powered assistant, capable of tailoring flight conditions to personal preferences. Lighting, temperature, seat position, all customizable. The plane itself would monitor weather, traffic in the air corridors, and battery levels.
Well, where, when, or where we do I, where it growls, where I want to.
The cockpit wouldn't just be a panel of gauges. It would be a streamlined digital command hub, with Tesla's AI co-pilots helping reduce pilot workload. In some cases, flights might even become fully autonomous, eliminating human error, the leading cause of aviation accidents. Durability is another critical challenge. Aircraft endure enormous stresses, rapid pressurization cycles, temperature swings, aerodynamic loads. How could a Tesla electric plane be both ultra-durable and lightweight? The answer once again lies in materials and design innovation. Carbon composites resist fatigue and corrosion far better than metal. By incorporating advanced resins and nano-engineered reinforcements, Tesla could design airframes with lifespans far longer than conventional aircraft. Where aluminum structures might need costly inspections and replacements after a set number of cycles, composite structures could be engineered to endure with minimal maintenance. That kind of longevity reduces costs, not just for airlines, but also for individual operators. On top of that, electric propulsion itself reduces wear and tear. Jet engines are marvels of engineering, but also complex machines with thousands of moving parts. They require constant maintenance, fuel systems, lubricants, and inspections. Electric motors, by contrast, are far simpler. With fewer moving parts, they offer longer service intervals and higher reliability. That means downtime is reduced, operating costs drop, and safety margins increase. Over time, these benefits add up to make electric planes not just competitive, but outright superior. Now imagine how this technology could ripple through society. Today, many people avoid flying for short trips because of the hassle. Airports are distant, boarding takes time, and flights themselves are expensive when compared to driving. But with Tesla's electric planes capable of vertical takeoff and landing, the entire infrastructure changes. You wouldn't need massive airports. You'd need rooftop pads or small regional hubs scattered across cities. Instead of driving hours to catch a flight, you could take an elevator to the roof of a downtown tower, board an electric plane, and be at your destination in less than an hour. This isn't just about convenience for the wealthy. It's about transforming mobility for everyone. The cost savings from eliminating fuel, reducing maintenance, and streamlining operations could make flights affordable for the average traveler. Think about what Tesla did with electric cars. Once considered expensive novelties, they're now mainstream options competing head-to-head with gas vehicles. A similar transition could happen with aviation. At first, electric planes might be niche, but as production scales and technology advances, They could undercut traditional airlines on short-haul routes. Entire industries could shift, with airports redesigning themselves for electric mobility, and city planners reimagining transportation grids to include airborne travel as a standard option. Of course, no disruptive idea comes without challenges. Energy density in batteries still lags behind jet fuel, which packs far more energy per kilogram. But the rate of progress is undeniable. Just a decade ago, the idea of a 400-mile electric car seemed outlandish. Now it's routine. With Tesla leading battery research, supported by breakthroughs like dry electrode manufacturing, solid-state prototypes, or aluminum-ion chemistry, aviation-grade batteries are not a matter of if, but when. The timeline aligns perfectly with 2026. When Tesla's other projects, from autonomous cars to energy storage, will have matured enough to integrate into a larger ecosystem. Imagine Tesla energy grids powering vertiports, solar city roofs charging local infrastructure, Starlink satellites providing global navigation and communications, and AI systems coordinating traffic in the skies. It's not just a plane, it's a node in a larger, interconnected Tesla vision for sustainable, intelligent mobility. Musk isn't designing isolated products. He's building an ecosystem where cars, planes, homes, and even robots all operate seamlessly together. So when we talk about Elon,